All right, guys, we're going to finish up our learning in this section 8.2. So I'm going to go ahead and move on to the next and final example that we're really looking at. And remember, we're going to really kind of just break this all down. And over here is my notes. So I have a place for my notes to continue from our lesson yesterday. Okay, so now we're really kind of looking at those real life problems. And I want this to be its own kind of thing because this is where everybody's head seems to explode because we're dealing with word problems. That's where math comes to life. So yes, you have to deal with these math problems and really kind of start to figure them out. Okay, so one thing I want you to notice is we've got a new vocab word here, and it's a really important one because it's going to come up all the time. So the zero of a function is the x value where f of x, the big thing here is I want you guys to remember that this is y equals 0. Okay, so it's also, so when that y value is 0, and that tells me my x value, these are also called our x-intercepts. Okay, so it's really important to notice that x-intercepts and zeros are really interchangeable words, and you may see both of them. Okay, so it's really kind of important. So here's our first example. So the function f of t, but we've been saying f of x, where's this t coming from? When we're dealing with our real life problems, most of the time you'll see an f of t. Because when we're dealing with quadratics, we're often, like I said in our last video, throwing things or launching things or dropping things. And we're calculating time based on time, right? So from the time I throw the basketball, from the time I drop the apple from the top of the building, those things. So we generally use a t in those parentheses as just a like, we're dealing with time here. Okay, so it's really nothing different. So f of t equals negative 16t squared plus s sub 0. That's how we would read that as s sub 0. Represents the approximate height in feet of a falling object t seconds after it's dropped from an initial height s sub 0 in feet. Usually that's what our little numbers below subscripted mean, or it's kind of like s sub 0 would be at initial, and then we'll see some later. So then we know an egg is dropped from a height of 64 feet. After how many seconds does the egg hit the ground is our first piece that we're looking at. So we can always draw a little lovely picture, right? So I'm dropping an egg off of a 64-foot tall building, which sounds kind of fun to me. If only I had a 64-foot tall building right now. Or an egg to spare. Okay, so what we're going to do is we're going to start with our function. So I've got my f of t equals negative 16t squared plus my s sub 0. Well, then I'm told here that this is the initial height, so how tall the building was. Well, this I was told was 64. Okay, so now I have f sub t equals negative 16t squared plus 64. Well, that's not what I was asked to do, right? So first I have to come up with my equation. So I'm asked after how many seconds does the egg hit the ground? So what we've done here right now, and you'll get a totally different way to do this here pretty soon, which you already kind of know how to do from our last unit. So what we can do here is make a table of values and sketch the graph. Or you could use Desmos and graph this. Okay, let me see if I can pull up Desmos. Yes, I have too many tabs open, I'm aware. It's been one of those days. Okay, so here's my Desmos. So when we're using Desmos, we always really do kind of just want to stick with X. It just makes it easier to read. Plus 64. Okay. So we can see here that there's the graph of this function. So one thing I want you to notice and to think of, because it matters, is back in our book, we don't have anything to the left of our y-axis. So why might that be? So remember, we're dealing with time. We can't have negative time. That'd be kind of cool, but it doesn't exist. So time starts and then goes forward. So we can never have any negative x values. So yes, even though your Desmos graph shows you the whole graph, we need to know that we're going to take our problem into context and say, nope, time is a positive thing. So we start at 0 and only deal with our positives. Okay, and so back to the question. After how many seconds does the egg hit the ground? So I want us to think just what we're looking at, because that's the most important part. So I remember that t, or in this case in our Desmos, x, is the time, which is our going across the x-axis. I remember that this, my y-axis, was the height in feet. So I know that something hits the ground at 0, right? Because that's where the ground is at 0 feet. So we can look back here and see, oh, when my y value is 0, when my graph has hit the ground again, my x value is 2. Again, I don't care about this one because we can't go back in time. So I could say that after 2 seconds, the egg will hit the ground. Okay? So then the second piece, part B, suppose the initial height is adjusted by k feet. How will this affect part A? So just think about this as a person first before you think about it mathematically. So if the building is taller, I would assume that the egg would take longer to fall. So if I increase that k, right, if that k value is positive, it's going to have farther to fall, so it will be a longer time. Just on that same fact, like if I was to drop an egg from the top of my roof at home, or from a shorter building, so if my k was to decrease, the egg's not going to take that long to fall. So just think about these things just logically before you try and rationalize it as math. So let's look at Desmos again. So if I was to increase this, right, so I add this k value to it, let's say to 100. Why not? Oh, it does take longer for the egg to fall if I add something to that. So what if I subtract something from it? We'll go with like 30. Oh, it takes less time. My x value is smaller, okay? So really spend some time thinking about those just logically of what is going to happen here, okay? So here's all the math words of everything we just said. That if k is greater than 0, so if I add some stuff to it, I add some height to my building, the egg's going to take longer. And if I subtract some height from my building, the egg's not going to take as long to fall. Okay, so really when we're getting into these word problems, I want you to think about them logically and just as a human before you start to try and think about them just totally math. Okay, that's really going to help a lot. So now that we've gone through this together and hopefully you have a little bit better understanding, now you're going to spend some time working through those word problems. And then once you're done with those, then you submit the assignment to me now that we have both parts done. Just remember, guys, you got this.